Hello and welcome. This is Barrett from the C4 Cyber Club here at Cypress College. And in this video, we're going to go over the Packet Tracer Lab for the CCNA1 class. This is for 4.6.5, Connect a Wired and Wireless Local Area Network. So I have the Packet Tracer file up here. We have the PT activity, so I highly recommend that you try and set yours up very similarly. That way you can work on the lab on the left or on the right, whichever side you'd like to place these on. But you have the activity list in the document to the right, and this is where it's going to show you the completion, and we're essentially going to go through these steps of connecting everything and eventually check our results, and we'll have green checks on all of these assessment items. Okay, so let me move this back. So you see we have our addressing table, all of the different devices, the particular interfaces we'll be connecting out of, and where they're connecting to. Just to go over the background here, so when working in Packet Tracer or an actual corporate setting, you should know how to select the appropriate cables and how to properly connect these devices. This activity will examine device configurations, selecting the proper cable based on the configuration, and then connecting the devices. So this is all a part of the physical layer module of learning the CCNA1. And we'll talk about all the various different types of connections. And the most important icon here you're going to click is the lightning bolts icon. And this is going to give you all of the different options of cable connections that we'll be working with. So going ahead and getting started on step one, connect the cloud to router 0. So we have router 0 here. We have the cloud up here. Now choose the correct cable to connect router 0, fast Ethernet 0/0 to cloud Ethernet 6. And this one already tells you which one we're going to use. We're going to use the copper straight through. So that is the second one in the list here, copper straight through. So we're going to select fast Ethernet 0/0, connect that to the cloud on Ethernet 6. Okay, and we immediately have the green indicators, so we know that that's a good connection. You notice on the lab, it says if you attach the correct cable, the link lights on the cable turn green. Step 2, connect the cloud to the modem. So we're going to be coming over here to the cable modem. So I'm sure a lot of you are familiar with your cable modem at home, and this uses a coaxial cable. So if we look down here, we could find the coaxial is the blue cable. And out of the cloud, we come out of coaxial 7. And you notice the icon here is different than we've been looking at before. This is the icon for a coaxial cable. And we connect that to the cable modem. And even without looking at the sheet, you could already tell just by the icon, we need to select the coax port 0. Okay, so that one's correct. So we've got everything connected to the cloud that we needed. Now part 2, we're going to connect router 0 to other devices. So we're going to connect first to router 1. So it says choose the correct cable when connecting router 0 to router 1, and we're going to be using the serial port. And this is a point-to-point connection. We could find the serial connection down here. So you can kind of consider this a local area network connection. So we're going to select serial 0/0/0 into router 1, serial 0/0. And we immediately have the green lights. Now connecting router 0 to this netacad.pk, you can kind of consider this like a server. This is important because, above we use the straight through cable, but here you see routers and computers traditionally use the same wires to transmit on 1 and 2, and to receive on 3 to 6. So if you're dealing with two devices that are using the same wires for transmit and receive, you need to use what's called a crossover cable. And you'll find that down here. It's the one with the dashes. Because what's happening is in the cable itself, the wires are crossed so that on the receiving end, it's not on the same, transmit on one end is going to cross the cables to make sure that it's sending to receive on 3 and 6. So we'll select the crossover cable here. And from router 0, we select fast Ethernet 0/1. And on the netacad.pk server, fast Ethernet 0. And just to show you an example, if you had, I'm gonna hit the delete icon here. I'm gonna remove that. If you had by accident selected that the straight through cable, you're gonna see red. So Packet Tracer is telling you that's no good. You're using the wrong cable. So let's go ahead and select the crossover again. Now we're good to go. Okay, so connect router 0 to the configuration terminal. So this is from something from the very first labs that we had done in configuring a router and a switch, and we did that using that physical console cable. So that's going to come out of console port on the router into the RS-232 port on the configuration terminal. All right, so we see we're already at 62% here, so we're halfway through. Now we're going to connect router 1 to the switch down here. And to do that, we can use a straight through cable because remember, these are not similar devices. So if we were using an Ethernet cable to connect router to router, for example, that would require a straight or a crossover. If we connect switch to switch, that would require a crossover. But in this case, we're connecting router to switch. They are technically different end devices, so we can use a straight through cable here. Okay, so we'll, and actually, now that I remember, this is kind of a trick question, and I notice it once we go to actually select the port. So I could have done something where I actually, looked at the physical machine and determined that it's actually an optical port. But I noticed it here when I chose the copper straight through. And then I noticed, well, if it's wanting to come out of fast Ethernet 1/0, this icon here, that denotes an optical connection. So I'm going to exit out of that cable and locate the fiber selection. So this is something we could select the fast Ethernet 1/0, and we're going to come into the switch fast Ethernet 0/1. So the difference with, and actually here's a good point. If you see this orange, don't worry. It's just, since we are running in real time here, it'll take a moment to catch up. If you want to make that green quicker, you could press this fast forward time and it's going to move forward 30 seconds. And I believe Alt-D is a shortcut for that as well. Now I was just about to say the difference between a fiber optic connection and an Ethernet connection is, an Ethernet connection is transmitting electromagnetic signals, right? It's the signal is pulsating through zeros and ones through an electric signal. But a fiber optic cable uses light. So it's basically the light pulses that send that information, and it is much faster. But with that faster speed, it does actually cost a lot more money as well. So that's something to determine when you're setting up a network. What can you afford to run and what kind of speeds do you need? Okay, so now we will connect the cable modem right here to the wireless router. So in this case, we can just use a straight through cable. We're going to come from the cable modem port 1 into the internet port. And now we'll also need to connect the wireless router to the family PC. So we can choose this copper straight through again, go from wireless router Ethernet 1 into fast Ethernet 0. And you see we have that orange dot there. We can go ahead and fast forward. Now we have all green. And at this point, we are at 100% completion for the connections. And we can go ahead and verify these. So we can open the family PC, go to the command prompt, and we could ping netacad.pka. I believe this will take just a moment, because essentially what it's needing to do, it's needing to make some ARP requests first, determine the MAC address, and then we should see some pings back once it's made that connection. Okay, and there we go. We have 4 ping requests received back. And we could also verify, we come back here, we can actually open a web browser. And we could visit http netacad.pka. And you can see that loads a very basic website, but we could verify that that connection is correct. Okay, step 2, ping the switch from the home PC. So I'll come to command prompt, and now we just need to reference the addressing table up top here. We could find the IP address of the switch. That's 172.16.0.2. Okay, and we got that back now. We had a couple successes here. This is pretty common when you're pinging something for the first time, because remember how I said it needs to send out an ARP request, an address resolution protocol. It needs to update addressing tables with MAC addresses along the way. So until it has that information, you may see a timeout or two. But if I ran that again, you'll see a much more instantaneous response from that, because the addressing table has been updated after that ARP request was made. All right, now let's see, where were we at? Open router 0 from the configuration terminal. Okay, so we can go to this terminal here, run the terminal, and you could see we are connected to that router 0. And we could also show IP interface brief to view interface statuses. Great. Okay, and finally we could examine the physical topology. So it's kind of a handy feature in Packet Tracer. There's this physical button up top here. And if we click on Home City, we could see we have all these different networks that we've set up. So first step here, let's examine the cloud. And we could actually take a look at the hardware that we have set up here. So, you know, the question here is asking how many wires are connected to the switch in the blue rack. Well, we have 2 wires. And we can go back and take a look at the primary network. And if we zoom out up here at the top, we could see we actually have the physical table. The question here was, what is located on the table to the right of the blue rack? That's the configuration terminal. If I zoom back in, you can get a much more detailed look at all this. So that, you know, Packet Tracer is really great in simulating a real environment, which especially comes in handy as you're learning during a global pandemic as well. So if I go back again, press this back button, And we're going to take a look at the secondary network. Okay, so it's asking, why are there 2 orange cables connected to each device? So those orange cables, let me zoom in here. You'll see here and here. Those are related to the optical connections. And the reason why you're seeing 2 is that one is for sending and one is for receiving. It's essentially how optical connections work. I'm going to go back one more time. We'll examine the home network. And yeah, so these are set up on tables. So let me go ahead and zoom out. And you see we have the family PC, the home PC, the cable modem, home printer, and wireless router. So I'm sure a lot of you might recognize this. This is very similar to what a lot of us would have set up at home. You're definitely going to have the cable modem and the wireless router, and then various PCs or maybe laptops or phones, which your family members are using. And as you complete the lab, if you don't have 100% completion here, remember you can come to check results, view assessment items, and that's going to show you exactly which section you may have missed. And then you'll see a little X, red X on there. But you can see in the lab and what we'll walk through, we got everything correct. So that completes this lab for Packet Tracer 4.6.5, connecting a wired and wireless local area network. Thanks a lot for watching.